Hi, everyone. Welcome. Thank you for joining us today. I'm Kelly Pirtle with NOAA Communications in Norman, Oklahoma, and I'm a member of NOAA's Central Regional Collaboration team, and I'm your host for today's webinar. I'm very excited to kick off our 13th 3-Minute Thesis Webinar. These speakers have some interesting and very timely information to share with us, and I can't wait for you to hear their presentations. Today's webinar is focused on air quality, which is one of NOAA's thematic areas under NOAA's One Health, an effort to apply a coordinated, collaborative, multidisciplinary, and cross-sector approach to address potential or existing risks that originate at the interface of humans, animals, and ecosystems. The One Health concept recognizes that the health of humans is inextricably linked with the health of animals and the environment. There are several other thematic areas: diseases, extreme conditions, benefits from the sea, and aquaculture. Ours is the final webinar of a series on these topics, organized in support of the first NOAA One Health Summit, which will convene in Washington, D.C. next week, and will bring together scientists, practitioners, and leadership across the agency to connect and highlight NOAA's work on health and related issues. Our presentations will include exciting research and forecasting capabilities, volcanic ash impacts, dust storm prediction, and the recent impacts from Canadian wildfires, and more. Each of today's panelists will have just 3 minutes and 1 slide to cover their topic. This format is based on a model used by universities across the country as a way to briefly share information about a project, initiative, or research. You can see from the outline, after each group, we will take a break for questions from you, our audience. And near the end of the hour, all of the panelists will return to respond to your questions for a few minutes. At any point during the presentations, please submit your questions in writing using the questions pane of the GoToWebinar panel. Asia Shumalo, the coordinator for the NOAA West Regional Collaboration Team, will be taking your questions and sharing them with our presenters. We're also being assisted today by Bethany Perry, the coordinator for the NOAA Central Region Collaboration Team. I'd also like to thank Margaret Simon for her help as well with putting together this webinar. We are recording today's webinar, and it will be shared via email and available on the NOAA Central Region Team's webpage next week. Finally, we'd really love to get your feedback on this event. Please take a moment at the conclusion of today's webinar to complete a very brief survey. So let's get started. The NOAA One Health program was kind of new to me and might be to you as well. So that's why we thought we would include an overview as a perfect way to kick off our webinar. We're excited to have Morgan Zabow with us to do just that. She is the Community Heat and Health Information Coordinator with NOAA's Climate Program Office. In this role, she works on 2 major programs: the National Integrated Heat Health Information System and NOAA's One Health program. As part of the NIHIS team, she co-leads an interagency heat communications team, which includes large-scale federal social media campaigns and creating infographics and messaging for heat preparedness. And she also leads NOAA's citizen science urban heat island mapping campaigns going strong this summer. Morgan will be presenting on NOAA's One Health program. Morgan?
Thanks, Kelly, and apologies if my camera goes in and out. I got a notification my internet's a little unstable. Thank you to all the organizers for having me today. Today, I'm going to be speaking to NOAA's One Health program, which brings NOAA capacity to understand, observe, and predict environmental, animal, and human health. And again, if you're unfamiliar with the concept of One Health, as Kelly mentioned, it involves applying a coordinated, collaborative, multidisciplinary, and cross-sector approach to address potential or existing risks that originate at the interface of humans, animals, and ecosystems. And NOAA has a One Health group, which includes researchers and programs from across all line offices. And we look to advance NOAA science and services to inform health decisions through improved understanding of the linkages between environmental conditions and health outcomes, and delivery of useful prediction products, data, and tools. And this team meets monthly on the first Thursday of each month. And if you're interested in joining this team, please make sure to email me and we'll add you in. But some of the tasks of the NOAA One Health group and the health researchers and programs in NOAA include communicating relative science and services to health decision makers, identifying and promoting innovative science and services, developing tools and technologies, facilitating the transfer of research to applications, promoting commercialization of applications, and much more. And also, as Kelly mentioned, we have 7 thematic areas that connect NOAA One Health. And these include extreme conditions, so heat, drought, severe weather, benefits from the sea, which include marine products and nutrition, the new blue economy, aquaculture, really looking at environmental assessment, spatial analysis, disease modeling.
We're going to give her internet another second to come back.
Island mapping campaigns, marine mammal stranding response program, and so much more. And specifically for air quality, the NOAA One Health Group seeks to increase synergy and coordination between the NOAA line offices on air quality products and services, engage partners to gather requirements for air quality and radiological modeling to provide decision support services, and develop collaborations with CDC and NIH and other agencies on products that study linkages between air quality and respiratory and cardiovascular health. And also, as Kelly mentioned, the NOAA One Health team is hosting the first NOAA One Health Summit, which is going to take place next week, August 15th through 16th. This summit is going to bring together scientists, practitioners, and leaderships across the agency to connect and highlight NOAA's work on health and related issues that support the One Health approach. And you can still register to attend the virtual portion of the meeting by visiting the NOAA One Health website. And thank you so much, and I look forward to your questions.
Thank you, Morgan. And it looks like we're having trouble finding the questions panel. So if you have a question, put it in chat. You can choose to send to just the organizers only, and that way we can receive your questions. So that really helped us understand, Morgan, how NOAA's role in this important work. Next, we're going to hear about NOAA's program that provides operational air quality forecast guidance to its partner agencies and the public to further the National Weather Service's mission of protecting life and property and the enhancement of the national economy. Dr. Young-Sung Young is the program manager of the National Air Quality Forecast Capability Program at the NOAA National Weather Service Office of Science and Technology Integration, the Modeling Program Division. She participates in various interagency activities related to air quality, including a number of working groups and councils. She is also a project lead in short-range weather convective allowing models, data assimilation, overall physics, and fire weather research in the modeling program. Take it away, Young-Sung. We can't hear you. Are you muted?
Oh, I'm sorry.
No, that's okay. Go ahead. Yeah, start again, please. Thank you.
Thank you, Kelly. As Kelly mentioned, NAQFC is NOAA's air quality program. In the United States, air quality forecasting relies on the three-way partnership among NOAA, EPA, and state and local agencies. State and local agencies provide monitoring data and emissions over their respective areas. EPA collects those monitoring data, maintains national emissions inventory, and develops air quality models. NOAA integrates EPA's air quality model into NOAA's air quality modeling suite, further develops and evaluates them, and provide operational air quality forecast guidance for ozone, smoke, dust, and fine particulate matters, known as PM2.5, to state and local agencies. Then state and local agencies issue official air quality forecast in the form of Air Quality Index, AQI. EPA interprets and disseminates real-time monitoring data and AQI through airnow.gov website. NOAA also disseminates air quality alerts and forecasts in coordination with the state and local agencies through weather.gov. This partnership was endorsed by the Memorandum of Agreement between EPA and NOAA. NAQFC hosts the annual Air Quality Forecasters Focus Group Workshop to bring together the NOAA Air Quality Model developers, state and local air quality forecasters, and representatives from other partner agencies such as EPA and Environment Canada. The main goal of the workshop is to strengthen our partnership. We also review NOAA air quality model performance and discuss research gaps and air quality forecasters' needs at the workshop. Within NOAA, air quality forecast model development is a collaborative effort among NWS, OAR, and NESTIS. NAQFC comprises three models: the Community Multiscale Air Quality Model, CMAQ, coupled with the GFS for ozone and PM2.5, REP smoke for smoke, and high split for dust. The AQM model in the NSEM production suite specifically refers to the CMAC component. Currently, operational product contains hourly forecast up to 72 hours of ozone and PM2.5 nationwide, and smoke nationwide and dust over corners up to 48 hours. Clicking operational air quality forecast guidance on the slide will lead you to the prototype air quality product viewer. NAQFC program also supports the global atmospheric composition model, one of the members of the global ensemble forecast system known as GAPS aerosol, which produces smoke and some other aerosol sources, and on-demand high-split model, which is used for volcanic ashes, radioactive, and chemical event. More information about the NAQFC can be found at the STI modeling website shown in the lower right corner of this slide. That's all I have. Thank you.
All right. Thank you, Young-sun. These products are very important, and it's good to learn more about them. We are working on the question issue, and
it looks like it's resolved now, so people should.
It looks like it's resolved, so please do submit your questions. Thank you so much. Our next speaker is Walt Schalk from NOAA's Air Resources Laboratory. He is the director of the lab's Special Operations and Research Division, located in both Las Vegas, Nevada, and in Idaho Falls, Idaho, working in a NOAA partnership with the National Nuclear Security Administration and the Department of Energy. Tell us more, Walt.
Well, good afternoon, and thank you for that great introduction and putting all of this together and the invitation to speak today. Much appreciated. As I said, I'm the director of the Air Resources Laboratory Special Operations and Research Division, located in both Idaho Falls, Idaho, and Las Vegas, Nevada. A little history: SWORD was born in the nuclear era. First was our support to the Atomic Energy Commission that began to develop nuclear energy, which began in 1949 in Idaho. Shown here in the upper left-hand corner is the first experimental breeder reactor #1, which was the first reactor to produce usable amounts of electricity. And then second, everybody who's watched Oppenheimer, we were heavily involved with the support of nuclear weapons science, which began in 1957 for us in Nevada with experiments Project 57, and shown here, the experiment Upshot Knot Hole. Interagency agreements have been in place between NOAA ARL and the Department of Energy and the National Nuclear Security Administration for us to conduct basic and applied research on common interests between the two departments, with a mission to provide a comprehensive atmospheric sciences and meteorological monitoring program for the Idaho National Laboratory in southeastern Idaho and the Nevada National Security Site in southern Nevada. SWORD conducts meteorological data collection and analysis to provide support for wildland fires and emergency response in the form of plume dispersion modeling, participation in national security experiments, provide climatological and weather data for environmental compliance and annual site reports, conducts weather surveillance to support site operations such as crane operations and digging activities, and also explosives research, and to provide severe weather and specialized forecasting to these specific DOE sites. SWORD is the application of ARL research and provides feedback to research in the areas of the prediction of hazardous materials transport, like plume dispersion modeling, atmospheric processes in complex terrain, boundary layer characterization with a focus on the desert environment, and to support safe operations on the Idaho National Laboratory and the Nevada National Security Site. SWORD accomplishes these missions using a variety of instrumentation. Along the bottom of the slide, you can see examples of our weather towers, which we have over 30 in Idaho and also over 30 in Nevada. A web display of our data, which is how we distribute, the primary method we distribute the data to our customers. A mobile radiosonde and upper air balloon system with a balloon being released from our mobile weather operations trailer. A portable weather station, an atmospheric profiler called a SODAR, which uses sound to provide a vertical profile of winds, and a lightning detection sensor from our dedicated network in Nevada to support the explosives research. SWORD is the applied research arm of ARL, providing preeminent atmospheric science to the DOE, NNSA, and NOAA. Thank you.
Thank you all. We said it was relevant. We have even had a reference to Oppenheimer, so there you go. We will now take a few minutes to address some questions. You can type your questions now in the chat pane of the GoToWebinar control panel. Asia, do you have some questions?
Thank you, Kelly, and thanks to our panelists for your excellent presentations. I'll start with a question for Morgan. Morgan, what NOAA programs, line offices are involved in the One Health program?
That is a great question, and there are too many to be able to answer in this particular, in a short amount of time. But as I mentioned in my presentation, every line office is represented in the NOAA One Health group, and we're looking to expand and make sure that all of the programs within NOAA that are directly or indirectly related to, as I said, ecosystem, animal, plant, human health are represented in the NOAA One Health group. So if you're interested in learning more about the group and want to join, please email me and let me know. I'll put my email in the chat.
Thanks, Morgan. Our next question is for Youngson. Youngson, how do we interpret the model guidance ozone or PM 2.5 concentrations with respect to human health?
That's an excellent question. The model predict concentration, which may be difficult to assess whether I should be worried or not. The AQI is EPA's index for air quality, and it links the air pollution, for example, like ozone and particulate matter concentrations, to health effect. And on the prototype air quality forecast guidance viewer, you can see the FAQs menu at the top. Please visit the FAQ site to learn about the level of concern and also suggested action for model predicted concentrations in your area. Thank you.
Thanks, Youngson. A question for Walt now. You mentioned support for wildland fire activities. That's currently an important topic. How do you support those activities with your office?
Well, we have a really close relationship with the fire department on our site. And, you know, that lightning detection system that we have out there is incredibly, a key part of this is that when we provide a forecast for thunderstorms during a day, we communicate that with the fire department, and they ask for where these storms may occur on the site, and they will actually send out a patrol to be in the area watching for the storms and to see if, lightning does strike and hit the ground and start something on fire, and then they can put it out right away before it gets to be any kind of big significant event. So our relationship with the fire department is very close, to support that activity. And then if it does start, we're there to provide all the weather support for ground activities and also any flight operations that do happen as a result.
Thanks, Walt, and thanks to all the panelists for those great answers to those questions. Kelly, I'll turn it over back to you.
Thanks, Asia. Thanks, panelists. Our next speaker is Brian McDonald. He's an environmental engineer and program leader with NOAA's Chemical Sciences Laboratory. He will tell us about a massive air quality research effort taking place this month. Scientists from NOAA, NASA, and 21 universities from 3 countries are deploying state-of-the-art instruments to investigate how air pollution sources have shifted over recent decades. The largest campaign, called AROMA, of course that's an acronym, has NOAA scientists and collaborators operating 30 specialized instruments aboard NASA's DC-8 flying laboratory, collecting a myriad of chemical measurements over highly populated cities, including New York City, Chicago, Toronto, and Los Angeles. NOAA Administrator Rick Spinrad called it an unprecedented scientific investigation in scope, scale, and sophistication of an ongoing public health threat that kills people every year. Tell us more about AROMA, Brian.
Thank you for that introduction. So just to give some motivation behind AROMA, currently over 100 million Americans breathe unhealthy levels of air pollution. Just to put that in context, the bottom left figure shows the annual US premature mortality for ozone and PM 2.5. And as you can see, it's a fairly large number of people that are impacted. And this is shown relative to other weather-related events as well and hazards. Another motivation is that the sources of air pollution are also changing with time. NOAA research has shown that there are emerging sources of pollutants coming from what are called volatile chemical products. These are everyday chemical products that we use: coatings, inks, adhesives, personal care products, cleaning agents. And these are sources of volatile organic compounds, things that you can smell, and that react in the atmosphere and form ozone and PM 2.5. So what NOAA and working together with NASA are doing this summer are making more measurements in cities across North America. As mentioned, the largest of these is on the NASA DC-8 aircraft. On this aircraft are roughly 30 sophisticated pieces of instruments measuring everything from greenhouse gases to air pollutant gases to aerosols and fine particulate matter in the atmosphere. And this aircraft is able to fly really low near the surface where people live, and also fly very high to be able to connect measurements that are made at the ground with the air, with also satellites that are also able to detect air pollution. So all these measurements hopefully be helpful to improve NOAA's air quality forecast models, as well as satellite products in the future.
All right, thank you, Brian. Really interesting research. Our next presentation is timely as well. What do spy balloons, train derailments, and greenhouse gases all have in common? Well, that would be the use of NOAA's high-split atmospheric transport and dispersion model. Mark Cohen is going to tell us more about it. And I'd like to say he is definitely an expert. He has been developing and using the model for more than 30 years and is currently the leader of the high-split modeling group at the NOAA OAR Air Resources Laboratory. Mark, tell us more about how it works.
Thank you very much, Kelly. The high-split atmospheric transport and dispersion model has been under development for 75 years. We started with the task to find the location of the Russian nuclear test site based on downwind radioactivity measurements. The model is driven by meteorological models and measurements from NOAA and elsewhere. It's predominantly used to answer two types of questions. The first is, where do things in the air go? For example, pollutants emitted from a man-made or natural disaster. And the different applications, I've shown a few here. One would be things like industrial accidents, like the recent train derailment in East Palestine, Ohio. We're trying to answer the question of what concentrations of pollutants will people be exposed to downwind, to be able to determine, where and when there should be evacuations. We also apply the model to volcanic eruptions to be able to warn aircraft away from regions of dangerous ash concentrations that could cause their engines to fail. Another application is for real or potential accidents at nuclear power plants. Example shown here is some simulations as to what might happen if one of the power plants in Ukraine had an accident. The model is also used for wildfires and for planning prescribed burns and for forecasting dust storms. In these applications, it's used operationally for emergency response to a real event, but it's also used to help plan and assess the risk from a potential event. The second type of question that we use the model to try to answer is, where do things that we see in the air come from? So instead of running the model forward, we run the model backwards to see where air parcels that arrived at a given location came from. One common application is to carry out so-called back trajectories. An example in the upper right shows a back trajectory of air parcels that arrived in Montana on a certain day when the spy balloon was seen, and then you go backwards in the atmosphere along the wind fields to see where that air came from. And you can see that the trajectory shows that the balloon could have come from China. And another important application to run is to run the model backward from atmospheric measurement locations in order to estimate the location and amount of emissions that must have occurred upwind to have caused the measurements to be what they are. And one example of this is the image in the lower right, where we're involved in a multi-agency project to estimate greenhouse gas emissions from the Washington, D.C. urban area, and based on measurements of the greenhouse gases in the region. So in essence, we're determining what the emissions of greenhouse gases must have been in order to explain the measurements of greenhouse gases that we see in the region. These so-called top-down emission estimates are used to check conventional bottom-up emissions estimates to independently verify claims of emissions increases or reductions, but they are also used in other applications, including wildfires, volcanic eruptions, and nuclear accidents. Thanks very much for your attention.
Thank you, Mark, for that presentation. Our next presenter is Carrie Womack. She is a research scientist at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado and works at the NOAA Chemical Sciences Laboratory. Her research focuses on building and deploying instruments to measure trace gases and aerosols and using these observations to better understand chemical transformations in the atmosphere that lead to poor air quality. She's going to tell us about a specific case where research identified an issue that was solved quickly with state-level legislation. Carrie?
All right, great, thank you. So I'm going to talk today about some work that my group did in Utah several years ago that recently led to a bill being passed in the Utah State Senate. So as you may or may not know, Salt Lake City has some of the most polluted air in the US in the wintertime, because pollutants can get trapped for up to 2 weeks in this mountainous terrain, like you can see in the picture here. In 2017, I was part of the Utah Winter Fine Particulate Study, which was measuring particulate matter, or PM2.5, on the NOAA Twin Otter aircraft, shown here. And somewhat by chance, on the very first day of the campaign, we intercepted the plume of a magnesium refinery that's on the west side of the Great Salt Lake, and shown in the bottom picture here. And in that plume, we saw extreme levels of halogen-containing species, namely chlorine and bromine, emanating from that plant. And using a plume crossing technique that's illustrated in the bottom left of this slide, we developed an estimate for these emissions that matched pretty well to the facility's own emissions for the chlorine species, but there is no national inventory for bromine, so they did not have to report anything. But our estimates indicated that there really was a lot of bromine there. Bromine is related to chlorine and is less prevalent in the atmosphere generally, but it's also more reactive. So we really wanted to understand the effects of these emissions. So during the rest of the campaign, we kept picking up these signatures of bromine throughout the area, as indicated by this map, with the colored dots overlaid on our flight tracks, and yellow indicates higher concentrations. So these widespread observations really showed that the plume, although diluted, was reaching these populated areas on the east side of the lake, including Salt Lake City. So my colleague, Siwon Wang, used the 3D chemical transport model CAMChem to estimate what the effect of these halogens would be on air quality, and the results are shown on the right. And essentially what he did was he compared 2 model runs, one with the halogen emissions from the plant and one without, and then compared the estimated amount of particulate matter and saw that there was anywhere from about a 10 to 25% change in the particulate matter in the populated areas shown in this black line. So we published this paper in January of this year. And in February, House Bill 220 was introduced to the Utah State Legislature, and it would mandate that the state compile an inventory for bromine emissions within the next about 2 years or so. That bill passed and was signed by the governor of Utah in March. And from our perspective, it was fairly surreal for all of us to see this happen so fast. But it was also really gratifying because the quality of our models going forward, determining the effect of these halogen emissions really depends on getting a more direct estimate than what we could do with the airplane. And this bill will hopefully make that happen in the next year or two. And that's what I've got. Thanks.
All right. Thank you, Carrie. That's a true life example of research making a real difference. It's now time for some questions. We appreciate those of you in our audience who have submitted them. Remember, if you have a question, type it in the questions panel of the GoToWebinar control panel. Asia?
Thank you, Kelly, and thank you, panelists. My first question is from the audience and for Brian, and it's from Stefan. And the question is there an effort to monitor sulfate haze generation and movement?
Sulfate haze generation and movement. I mean, on board the aircraft, there's a bunch of instrumentation that can measure sulfurous compounds in the gas phase as well as in the particle phase. So just in general, in addition to sulfur, right, we can track a lot of various other pollutants from the gas to particle phase and then understand their impacts on regional haze. In addition to sulfate, right, there's also a lot of haze that's being generated in the East Coast this year from wildfires in Canada. And so many these fires are also intersecting some of these cities while the flights are being made. But yes, we can measure those species and their transport.
Thanks, Brian. Appreciate it. We'll hear about Canadian wildfires later. The next question is from Mark, and it's from Katie. Is the high split dispersion output for wildfire smoke available publicly online?
We are developing a new system. Right now, you can go online and do a prescribed burn run. A lot of state agencies and fire departments use these if they're thinking about doing a prescribed burn. Right now, the NOAA operational forecast is being done by another model. It's a follow-on from her smoke. So there is definitely a NOAA operational wildfire forecast site. Right now, it's not high split, it's not that model.
Great, thank you, Mark. The next question is for Carrie. How do these halogens lead to high particulate matter?
So that is something that was sort of part of the reason it took us a while to get this paper published, because it's not that the halogen species become particulate matter, it's that they accelerate the reactions between other things in the atmosphere that takes other pollutants that are also being emitted in the area and really accelerates their conversion from the gas phase into the particulate phase where they form particulate matter.
Thank you, Carrie, I appreciate that. We'll go back to Brian. How will aroma data help improve forecasts of urban and regional air quality and advance the health of our nation?
Yeah, thank you for that question. One way is collecting the data. You collect a lot of species relevant to air pollution, including gases that are directly emitted, so things like nitrogen oxides, volatile organic compounds, ability to measure species from their emissions to reactions in the atmosphere in the presence of sunlight, so their ability to form PM 2.5 and ozone. And we work together with our other OAR laboratories and with Weather Service to use this data to evaluate, for example, output from the National Air Quality Forecast capability that was mentioned earlier. Use that data to improve our understanding. Are we putting in the right emissions? How is the meteorology performing? For example, for fires, the long-range transport, how is that represented? So having real-world observations is really important for identifying areas where we can improve the models that we use to also forecast poor air quality for the public.
Great, thank you, Brian. We'll do one final question from Mark, and this is from David. Is there a plan to add volcanic ashfall to the surface to high split?
Sorry, a plan to add volcanic ash, what?
Volcanic ashfall to the surface.
Oh, ashfall. Yes, it's a good question. It does affect things like airports and other places. And we actually are calculating that in the model. And it's not being sort of required by the aviation authorities because they're more concerned with what's going on in the air. But we absolutely are going to try to make that product available as well.
Great, thank you. Thank you, audience, for the questions, and to all of our panelists. Kelly, I'll pass it back to you.
All right, thank you, Asia. We'll now transition to our final group. When I think of dust storms, I think of the videos and photos of a big ominous dust storm overtaking a city. Dust storms can definitely be dramatic and deadly. You may have heard about the deadly pileup of vehicles on a highway in Illinois last May that was caused by a dust storm. Our next speaker, Barry Baker, will help us better understand NOAA's role in dust storm forecasting. Barry is a physical research scientist and leader of the Chemical Modeling and Emission Group at NOAA's Air Resources Laboratory. Barry?
Yes, thank you. So I'm the main developer of the FUNCSA dust emission model that's used within NOAA's operational modeling systems, and that includes anything from really fine scale to right around a 3-kilometer forecast to a global 25-kilometer forecast. And just to give you an idea of the importance of dust, dust makes up about 30% of the total aerosol composition in the atmosphere globally. It also has direct impacts on the radiative budget, the Earth's system budget, as well as impacts on cloud formation and precipitation. Aside from that, dust also has large impacts on human health, such as breathing particulate matter that Brian mentioned, but it also is a transport pathway for diseases such as valley fever in the Southwest U.S. And this is to not to discount the actual impacts of visibilities, that Kelly just mentioned for extreme weather events where a wall of cloud or haboob happens. And I actually am showing that dust event in Illinois here on these bottom 2 figures. But one of the things that we've done is, FUNCSA has been part of the National Air Quality Forecast since 2012, and it's now spread to many of the other applications and is becoming a larger focus for NOAA in general for all of its future operational weather prediction models, going into all of the next generation systems. But one of the things that we're able to do with developing these models and things is we're also able to develop things that can track the dust record, so we can re-verify our models and show the impact to human health. So the bottom left figure is essentially the climate warming stripes, but for the erodibility of the surface. And so this tracks not just potential dust sources, but potential trends in dust sources. And so we can see how this changes through time, and it gives us a bigger idea of the total impact of dust on the ecological system, human health, and weather impacts. Thank you.
Thank you, Barry. Our next speaker is Jamie Kibler. He is a meteorologist and manager of the Washington Volcanic Ash Advisory Center located in the Washington, D.C. area, which is part of the NOAA NESDIS Satellite Analysis Branch. Since 2010, Jamie has led many efforts during volcanic ash eruptions throughout the U.S., like Kilauea in Hawaii, as well as the Caribbean, Central America, Northern South America, and any efforts that needed collaboration with U.S. and international colleagues. He will share with us how NOAA monitors and forecasts volcanic ash and how that might impact us. Jamie, tell us more.
Thank you, Kelly. Like Kelly said, our group, which is a satellite analysis branch, within that is the Washington Volcanic Ash Advisory Center. We're located in College Park, Maryland, just outside Washington, D.C., and we're co-located right with the Air Resource Laboratory. We're one of 9 volcanic ash advisory centers around the globe, and the volcanic ash advisory centers came about in the late 80s to early 90s and became established officially in 1997, 1998 to forecast airborne ash from erupting volcanoes. So we monitor erupting volcanoes within our area responsibility, as Kelly mentioned, which is the U.S. and Hawaii, the Caribbean and Central America and North and South America, and parts of the Atlantic and Pacific, which includes the Marianas Islands. So what we do is we issue volcanic ash advisories, volcanic ash graphics, which you can see on my slide in the bottom right-hand corner, and we forecast airborne ash up to 18 hours. How do we do that? Is we monitor all forms of satellite imagery, geostationary, polar orbiting satellite, high-resolution satellite imagery, and we communicate with state volcano observatories, MetWatch offices, which is basically National Weather Service forecast offices globally. And we use all sorts of tools to communicate, NWS chat. We use the VolCat tool, which is Volcanic Monitoring Tool Kit, using different algorithms and other information to help us forecast volcanic ash and help us be alerted of potential volcanic ash eruptions. So our information goes to a wide variety of users in the aviation field, domestic international airlines, air traffic controllers and their centers. The information goes out to private sectors and researchers who want to kind of figure out eruption parameters for future eruptions. And this information also goes out to many other users. We work closely with some of the people that have been talking today at the Air Resource Laboratory. We work very closely with the National Weather Service, the FAA, or the Federal Aviation Administration, and we also work closely with the United States Geological Survey, which help us kind of figure out when volcanoes become active and when they may erupt. And this is all to help forecast airborne ash. So what is ash and why is it so dangerous? Is it can damage the engine and throttle components and other aircraft equipment. And this could cause delays. It could cause rerouting of airlines around volcanic ash. It could create emergency landings and at worst case scenario, even air crashes. And some of the information that we'll do in the future is quantitative volcanic ash, which allows airlines to fly through ash. So our main job is monitoring, forecasting airborne ash, and providing that information out to our aviation users around the globe. Thank you.
Thank you, Jamie. That's a really interesting role that NOAA plays.
Thank you.
Thank you. This summer has been remarkable, it seems like, in numerous ways, but one of them, I think, is because of the prevalence of smoke from Canadian wildfires that affected communities, especially in the northern part of the US. It was especially bad in New York City, where our final speaker, Nelson Vaz, serves as the warning coordination meteorologist at NOAA's National Weather Service Forecast Office. He will talk about how they leveraged NOAA technology and core public safety partnerships to observe, forecast, and communicate the impacts of the June 6th and 7th Canadian wildfire smoke event. This is an excellent example of how the National Weather Service fulfills its mission to provide weather, water, and climate data, forecasts, warnings, and impact-based decision support services for the protection of life and property and enhancement of the national economy. Nelson?
Yeah, thank you, Kelly. So yeah, this was really something that in the 40 plus years I've lived in this Northeast area, never experienced, and for the certainly the 20 plus years that have worked at the National Weather Service office in New York, myself and my colleagues have not experienced. So it was really learning on the fly what tools we can use in terms of observing, and especially forecasting the impacts of the wildfires and the smoke, and also how to communicate this to our partners who have to take public safety actions and prepare and respond for public safety. So one thing to note, we do rely on the expertise of our EPA and our state DEC partners. They're the ones who put out the air quality alerts and are really forecasting the air quality. What we're doing is forecasting the meteorological conditions, and then how is that, and also relaying their air quality alerts and communicating this information, interpreting for our public safety partners, for our media partners, so this can be, take public safety actions. So with any forecast, it starts with great observations, and we're very fortunate that NOAA has some great tools in terms of satellite. Talked about one of the previous speakers talked about the geostationary and the polar orbiting satellite imagery. Really allowed us to see how the fires across Western Quebec, Eastern Ontario were really starting to rapidly intensify and really explode in terms of smoke and the fire development. And to really see, and that was occurring on the 5th and 6th, and as we're going later into the June 6th, and the peak of the event was really June 7th for us, to see that smoke that was coming across the border, and then to be able to overlay meteorological information on it. What is the visibility that's being seen upstream, ceiling height, obscurations, and so really to get a sense of what was potentially coming down into our area. And of course, our EPA partners have their Air Now monitoring sites to really help us understand, how is the particulate matter that makes up the smoke, especially the 2.5 micron, how is that intensity or that concentration increasing? And that especially helps our state DEC partners. So in terms of forecasting it, we took those great observations. They also go into the weather models. So, just from a synoptic meteorology standpoint, we know there was an anomalously strong low pressure system off the Canadian or along the Canadian Maritimes that had counterclockwise winds that were going to transport this smoke directly from the Canadian wildfire source area right down into our area with potentially not much dilution. The only uncertainty was this smoke going to be at higher levels, or was it going to be down at the ground where it can affect people and have meteorological and air quality impacts? Well, another one of the great NOAA tools is the NOAA modeling, the high resolution rapid refresh modeling and the RAP modeling, which you see in the center on the right here, which really initialized the smoke plume very well and the outbreak or the increase of the fires. And what this was showing, like 8 o'clock in the morning, that we saw it initialize things well, and what it was showing by 5 p.m. later that afternoon on the 7th, that without much decrease in the concentration, that smoke was going to head down towards our area. So that helped us in terms of being able to provide, updated marine public aviation forecasts to really talk about the intensity, the decreases in visibility, the potential, the decreases in ceiling heights, and how that was going to affect maybe cloud cover, even precipitation. We did a lot of emergency management, public safety official consultation and interpretation, what this meant in terms of impacts, and and helping aid in terms of their public safety decisions. And also we did a lot of media interviews to help get this information out to the public. So I know we're already over time, but on the last slide, you can see the impacts and after actions. I think, a lot of the big thing was the change in conditions on the 7th, where early in the morning, we had some light smoke haze, and by later in the day, you can see in a viral social media post that we had with 9 million views, that conditions rapidly deteriorated. Luckily, it wasn't a widespread, high impact, life and property threatening event, but it did cause a lot of irritation, and especially for those with asthma related conditions, increase the impacts for them. So I'll stop right there, and thank you for the opportunity.
All right, thank you, Nelson. It's now time for questions about these last 3 presentations. Do you have some questions for us, Asia?
I do, thanks, Kelly. I'll start with a question for Barry. What type of impacts do dust storms have on society and human health?
Yeah, so it can have very large impacts, anything from soil degradation. So for instance, you think about the Dust Bowl that happened, in the last century. Those were dust, direct impacts on farmland and things like that, but it also has impacts on human health. We breathe these things. You can develop diseases from fungi that are transported whenever these dust emissions occur, such as valley fever. And, not in the US, but meningitis and those types of things are transported by dust as well. And so, yeah, dust has a, direct impact on human health, but also on the economy and the ecology that we have.
Thank you for that, Barry. I'm going to ask a question of Nelson while I wait for Jamie to come back on the screen. For Nelson, you said this rare smoke event was a learning experience for you and your partners. What are some of the practices you put in place to better help forecast and communicate the impacts of future wildfire smoke events?
Yeah, definitely a learning experience for us, Asia. So, after any type of high impact, or in this case, high visibility event, high attention event, we do a review of the science and service. So I think for us, it was coordinating. One thing was just we got a better understanding of the smoke modeling products that are out there that were discussed today. especially the HER smoke modeling and the RAP smoke modeling. Some of the newer products that are, the RFS, which is a new version of the HER smoke modeling product, and even, from the European centers, Canadian centers, so things we could look at, and especially looking at near surface smoke. So that was a big, the utility of the satellites and looking in terms of fire hotspots and how the smoke is developing, and really some of the 1-minute imagery, geocolor imagery, really important stuff for us. So these are all things that we're going to be able to use in terms of guidelines and best practices for our forecasters. This had also marine impacts and aviation impacts. So how do we go about it? And now we have kind of a plan in terms of how do we go about in the future to forecast this to help our aviation partners and also, for our marine partners. You can almost think of it almost like a stratus fog event that's affecting our marine and aviation partners. And then the other thing is working with our public safety partners to make sure and to help them in terms of creating their public safety preparedness and response plans. So we're working with New York City Emergency Management, helping to advise them what's the skill in forecasting some of the meteorological impacts, and as well as our state DSC partners are helping in forecasting what's the skill in forecasting the air quality impacts. So all those things together, in terms of the science and service, I think we're better prepared if another event does occur like this.
Great, thank you for that answer, Nelson. For Jamie, who are the groups you collaborate most with for volcanic ash operations on a daily basis?
Thank you for the question. We collaborate mostly with the state volcano observatories across our area of responsibility. They provide on-the-ground information and most updated information. And then we also collaborate with some of our meteorological watch offices. They provide SIGMA, which is the official warning of when a volcanic ash or volcano erupts. So, and on a daily basis, we may communicate with different airlines that maybe see ash or have any new information that may be provided on flight from one location to another. So, but our state volcano observatories provide us the best information because they have different people across their area of responsibility for on the ground operations, but they do provide us for our airborne operations for volcanic ash. Thanks.
Great, thank you, Jamie. And at this point, I'm going to welcome all of our speakers to come back on screen. I'm going to whip through a couple audience questions before we close out today. Hi, everyone. And so this first question I'm going to direct at Youngson from Jack. So he writes, unfortunately, we've had a lot of bad air, smoke from Canadian wildfires this year. At one point, I was a bit confused about the differing units between the smoke and then the PM 2.5 forecasts and the observed air now units. Can you share which forecast most closely matches the air now observed values?
So air now have several observations, and then the most popular one is PM 2.5, and then smoke is more close to the PM 10 that include the particles that is larger than 2.5 micron. So the PM 2.5 is what we typically see in the air now observation as PM 2.5, and then we produce both the smoke and PM 2.5.
Great. Thank you so much for that, Youngson. I have a question from the audience from David, and this is for Barry. Can this dust modeling be used for other sources, such as resuspended volcanic ash or glacial silt?
Yes, so it's a very similar process. So it could be used for that. The real trick is to know where those sources are. So resuspension of volcanic ash or old volcanic ash soils and things like that, that could definitely be used for this, but it could also be used for wildfire soot and things like that. So resuspension of wildfires or even microplastics. This is a big area of emerging science for us within the dust community, is to use it for microplastics and these other types of sources. Yes.
Great, thank you for that, Barry. I've got a question for Mark now. What are the biggest uncertainties in the high split model?
The biggest uncertainty is probably the meteorological data that goes into driving the model. And there's not a criticism at all of the meteorological models. It's extremely difficult, as we all know. And one of the biggest uncertainties there is going to be like the wind direction. So from a meteorological modeling perspective, if you get the wind direction within 5 or 10 degrees, that's actually quite good. But if you think about a plume going downwind from an accident, if you're 5 or 10 degrees off, the plume's gonna be going in a little bit the wrong direction. So again, not a criticism, but that's probably one of the biggest uncertainties.
Great, thank you for that, Mark. A question for Jamie. What happens when an airplane flies through volcanic ash, and are they allowed to fly through it?
So as of right now, for example, the Federal Aviation Administration, there is no policy to fly through volcanic ash. It's avoid, avoid, avoid. The 2010 eruption of Eyjafjallajökull in Iceland, that kind of put on everybody's mind that there's going to be situations where airlines are going to have to fly through volcanic ash. You can't have ash, for example, over the Northeast and shutting down, say, Boston, JFK, LaGuardia, and those airports up there for, say, 2 weeks, like what happened in 2010 in Europe. So we are putting together with many different groups, global, domestic, put together this data stream of information called quantitative volcanic ash. And this will allow people to make decisions to fly through low concentrations of volcanic ash if needed. And eventually, all 9 volcanic ash advisory centers will be required to put out these data streams when needed for high significant volcanic ash events. So this has been ongoing for about 12 years. Users want this information to make split decisions. But there are a lot of groups, aviation groups around the world who will not fly through ash. They will need to change their procedures and come up with ideas that will help them make decisions of when to do this. And we'll be part of that with quantitative volcanic ash. Thanks.
Thank you, Jamie. A question for Nelson. What's the historical context of the poor air quality for the New York City metro area with this event?
Yeah, so yeah, like I was saying, something I hadn't experienced in just 40 years, growing up in this area. So, we rely again on our EPA, DEC partners in terms of keeping the records and monitoring air quality levels. And I guess you have to really look at whether this air quality, the calculation, it takes into account numerous different factors. But what we were interested in is the air quality with respect to the 2.5 micron particles, most closely correlated with smoke particles. And so that, based on records going back to 1999, was the highest, daily average on record for the New York City, New Jersey, Connecticut metro area. I guess the one thing to note, if you look in the bigger picture in terms of how air quality has, improved. You had the EPA, the Clean Air Act in 1970, and then amendment in 1990. Air quality has really improved quite a bit since we, going through those periods. We used to have a lot of smog events in New York City if you go back in the 60s and prior. So what seemed to be, in this case, it's not so much these smog events, but it is in terms of this particulate matter, these smoke events, which may be the real kind of outliers in terms of these poor particulate matter air quality. And at least since records, EPA records, this is this was a record, is the one of record.
Great, thank you, Nelson. I'm going to do one more question for Morgan to tie this back to One Health. How can people get involved with One Health program?
Absolutely. Like I said at the beginning, we would love for all of you to join our One Health group that meets monthly on Thursdays. And feel free to email me if you want to be added to that list. And again, we really hope that you can all join us virtually for the One Health Summit that's taking place next Tuesday and Wednesday, and you can register for that online.
Great. Thank you, Morgan. Thank you all for answering those questions. This has been a really timely webinar, and it's been great to learn from all of you. We'll hand it back to Kelly.
Thanks, Asia, and thanks everyone. Man, this has been an excellent webinar. I love this format because we can cover so much. And as usual, I'm impressed with all that NOAA does to monitor and predict and ultimately protect us. A big thanks to all of our wonderful panelists today, coordinators Bethany Perry and Asia Shumalo, as well as you, our audience. I hope you have enjoyed it. If we didn't get to your question, we will pass it along to the panelists. And as a reminder, the webinar recording will be posted next week and can be found at the webpage added to the chat box. You can also find recordings of past webinars using that link. And as we end, please stay on for one more minute to answer a few brief questions that will appear on your screen. Your feedback really is helpful as we plan future webinars like this one. Thanks again for your participation and have a fine day.